Okay, on this question, it says at noon, ship A is 40 nautical miles due west of ship B. Ship A is sailing west at 80 knots, and ship B is sailing north at 21 knots. How fast in knots is the distance between the ships changing at 3 p.m.? Note, 1 knot is a speed of 1 nautical mile per hour. It's like a mile per hour thing. All right, well let's draw what we said. First step, we got to have a good picture here. Ship A is 40 miles west of ship B. So we got like ship A, and we got like ship B, and the distance between them is 40 nautical miles, right? Ship A is 40. Or you know the directions, then maybe that'd be helpful if I do that. Oops, make them straight. Be better. So, oops, I'm in a little trouble here. There we go. Okay, so this is north, south, east, and west. Okay. So A is west of B. A is 40 miles west of B. Ship A is sailing west. Okay, so ship A is going that way at 18 knots. That's 18. Basically, it's the same thing as it's a mile per hour, 1 knot. So I'm just going to say 18 miles now, nautical miles per hour, whatever. It's headed that way at a speed. That's a speed, 18 miles per hour. And this is just 40 miles, total nautical miles, whatever. And then B, ship B is sailing north. So it's going perfectly north at a speed of 21 miles per hour. Okay. And then the question is, how fast is the distance between the ships changing at 3 p.m.? Okay. So you know step number one, identify, whenever we have related rates problem, identify all rate letters. So all things that are mentioned with rates. Okay. Well, we've got what do we call it? dA dt. About that dA dt. That is going to be 18. Right? How fast ship A is moving this way. That's 18. Oh, actually, we need to call that something, don't we? Yeah. Why don't we call this X and call this Y? And so we'll actually say that that's dx dt. Dx dt, meaning X is the distance from ship A to where it currently is, right? Ship A is headed this way. So this is where ship A started. It started here. Ship A started right there, but it's headed west, isn't it? It's headed west. Okay. And so X, which is the distance from where it started, right? It's distance from here to here, that is changing at 18 miles every hour because the ship is going 18 miles every hour that way. So this distance is growing. It's positive. It's growing. The change in X over time, it's growing by 18 miles every hour. And Y, which is how far from where B started, this is where B starts right there, but then it's going up, 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 up. And that distance is growing by 21 miles every hour. So we'll say that dy dt dy dt is positive. These are both positives. They're growing, right? Y is growing 21 miles every hour, and X is growing 18 miles every hour. Okay, so we got those two things that are moving, right? Because 18 and 21 knots. How fast, okay, that's not its rate again, is the distance between the ships changing? Now what's the distance between the ships? Well, that'd be from right here to right there. That is the distance between the ships, right? Because ship A is I don't ship A is headed this way and ship B is headed that way. So if you freeze if this is an overhead video and we're watching, ship A starts here, ship B starts there, and Ship A starts heading this way and ship B starts heading that way. We freeze the video. Right now, how far apart are they? Well, it's that line right there. That's the distance between A and B ships. Ships. Oh boy, very well today. Ships A and B. So that makes sense because ship B is going up here. You might say, well, no, B's right here. And well, that's where they started, but ship A is going this way and ship B is going that way. So if you freeze the video, I mean, they'll keep going. Well, it goes higher. Yeah. And this keeps going. Yeah. But anytime you freeze the video, that line is going to be the distance, from where this one stops and where that one stops. That line is the distance between the ships. Anyway, call that Z if you want. You got X, Y, Z. Um, that is, I'll just say dz dt. I think that's what we're looking for, isn't it? That's what they're asking us for. Yeah, how fast is the distance between the ships changing? Okay, so there's our three letters. So step two, find an equation. How this works, right? Find an equation relating, rates, relating those letters only. You can have numbers, but in this case, it's X, Y, and Z. Those letters only and nothing else. No other letters, and you can have numbers. How we can do that? Well, I was gonna say that's really obvious, but it's not quite. A little tricky. The distance from here to here is 40 plus X, isn't it? Because from here to here, whoops, I went too far. From here to here is 40, and then this is X. So from all the way from here to there is 40 plus X, right? And from here to here, this side is just Y. And we know this is Z. So we have a triangle, don't we? And this is a right triangle, right angle right there. How do we know that is the case? Well, because this is straight west, this is straight north, so they make 90-degree angle. So we can do the Pythagorean theorem. Remember, a squared plus b squared is c squared. So I can take 40 plus x squared plus y squared is z squared. See that right there? Because again, this whole distance on the bottom isn't just, you might say, well, why isn't that just x? Well, because from B to A, they started out 40, and then x, and then it went, and ship A went x, which I don't know what that is yet, but it went some distance west, and this ship went some distance north. So this side's just y, this whole side is 40 plus x, and this is z. So there's an equation relating those letters only. There it is. Okay, step 3. DDT, both sides. So I'm going to do that. So I'm going to go, okay, DDT um, plus x squared plus y squared, DDT, that whole thing, equals, we're going to DDT z squared. All right. Also, so here we go. How do we take the derivative with respect to time of these things? So this guy first off, bring down the 2. You remember the chain rule? Lower the power by 1, so it'll be just first power, times the derivative of the inside, which will be dx dt, because that part just goes to 0, right? Right, so remember the chain rule. Chain rule says, do the outside, so do the 2 power, bring it down, lower by 1, and then go times the derivative of the inside, which is dx dt. The 40 just goes to 0. Plus, do the same thing here, bring down the 2, y, lower the power by 1, times dy dt, derivative of the inside function, which is just y. And then this side, bring down the 2, lower the power by 1 times the inside function, dz dt. Chain rule keeps making us go times 0 to the inside, even if the inside's 40 plus x, or the inside's just y, or just z. All right, so there we go. Now, step 4, plug in the numbers. Plug in the numbers. So, okay, now we got a lot of numbers here. Do we have x? What do we have up here? So we got dx dt. We got dy dt. So that's this and this. And we're trying to find dz dt. Okay. Okay, but do we have x, y, and z? Uh, no, we got to get those. Okay. So we got to do a little bit of work to get x, y, and z. How are we can do that? Well, that's when we go look at the whole thing about it says the ship is what's it doing? It's sailing west at 18 knots. Remember, knots is like miles per hour, nautical miles per hour. 1 knot is nautical mile per hour. So just say miles per hour. So ship A is going west at 18 miles an hour. Well, it said at 3 o'clock. So it started at noon and it goes to 3 o'clock. That's 3 hours. So X will be 3. Oops, that was a sloppy 3. 3 times 18, but it's just as bad. It's at 30, 24, it's at 54. X is 54 miles. See how I came up with that? Because ship A is going 18 miles every hour. And it does this for 3 hours times 18 miles per hour. You tracking with me? 3 hours. If you drive your car for 3 hours or your boat or whatever for 3 hours at 18 miles per hour, 3 times 18, you're going to cover 54 miles. So this X, which is the distance from where it started to how far it's gone, by 3 o'clock will be 54 miles west. So there's X. How do we get Y? Right over here, Y, same kind of thing. That's going 21 miles per hour for, again, 3 hours. 63 miles. So that's a ship B will have gone 63 miles north. 63 miles. An S in there. Well, won't let me do my S. I guess I'm out of room there. Miles. There we go. 63 miles north. Okay. So now Z is going to be the trickiest one. Z is for sure going to be the trickiest one. So let's bring down our X. Well, let's show you. How about I do it right? I'll do it right up here where you can see everything. Okay, redrawing the triangle. Remember this bottom part is 40 plus X. Right? 40 plus, and we just found out that X is 54, at least at 3 o'clock, which equals, what's that, 94? Right angle here. Y right there is 63. So I'll put that in red. 63 miles is miles. 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 Tracking with me, and this is Z right there. So again, the bottom part, right? They started out 40 away, and then ship A went west for 3 hours from noon to 3, at a speed of 18 miles an hour. So it went 54 more miles west. So 40 plus 54, ship A is way over here, a total of 94 miles west. And ship B is way up here, 63 miles north, right? Because it went 21 miles per hour for 3 hours. So it went 63 miles this way. Ship A is now 94 miles west. It started 40 and it went 3 times 1854 more. Now I can find Z, the distance between those. How do I find that? Well, a squared plus b squared is z squared. Get rid of this. I know I'm just kind of squishing this in wherever here. A squared plus b squared is, in this case, z squared, right? So we got 94 squared plus 63 squared is Z squared. So what does Z equal? Well, you know how to do this. You just root this and root. No, that's not a very good root, is it? And root. I can't do it. There we go. So there it is. Root of 94 squared plus 63 squared. All right, here we go. Plug in the numbers. It's getting ugly, isn't it? All right, bring down. So we got what? 2 times 40 plus x. What was x? Remember x? Well, it's 54. Oops, that's not what I meant to do. X is 54. So bring that down. Times dx dt. We had that somewhere too. There's a lot to this problem, isn't there? Where's dx dt, baby? Come on. There it is. 18. X dt is 18. Plus 2. And what's y? Y is 63 miles. Oops. And then dy dt is, isn't that 21? Dy dt 21. Yep. Okay. Equals 2. And then what is z? Well, z is going to be the square root of that whole thing, right? We found z right here. 94 squared plus 63 squared. And then dz dt. We're looking for dz dt. So we're going to divide this by 2 and not this again. Yeah, square root of 94 squared plus 60 squared. Boom, boom. Move you to one side. You got no choice. But do the same thing. Oop, that is not what I wanted. 2 square root of 94 squared plus 63 squared. Woo! This really right. It's been a lot of steps. So dz dt. I'm going to type all that in. Um, hmm, yeah, okay. 2 times 40 plus 54. Let's go to Desmos. 2 times 40 plus 54. Come on, Desmos. 2 times 4. This did I go too quick? 40 plus 54. And what else comes? 2 times 4 is 18 plus 263.21. 18 plus 2. Is that right? 263.21. Was that right? 263.21. Yeah, that's right. Okay. On the bottom, 2 square root of 94.63. 94.63. 94 squared plus 63 squared. Oof. 26, 6438, 26, 6438, 26. Oh, that's beautiful. 26, 6438. On she goes. So there it is. That was a lot of work. And there we go.